Dynamic strings. That is going to be the topic of today's video. We're going to jump right back into the YouTube series where I teach you guys how to build a programming language from scratch. And today we're going to talk about exactly how do you embed data inside of a string literal. So let's get right into it. What is up, guys? DevCode here, back with another video. So as you guys heard, we're going to be jumping right back into the YouTube series, and today we're going to be talking about how to build dynamic strings. So you guys saw in my previous video I talked about this, where you can basically put a variable here, or you can put an expression here by using the brackets. So let's get into how you can do this. This is something that's extremely easy to do. And if any of you guys want to build a programming language, I would highly suggest you add this feature. All right, so the first thing we're going to do is we're going to go back up to our front end part of the compiler, and I will eventually do a video talking about the architecture of the compiler. Here's the new compiler, and here's the old compiler. So whenever you want to add this feature, here's my suggestion. I suggest that you guys put it in the, now there's a reason for that. You guys don't want to make your language way too complicated. So you want to make sure that you add this feature at a very high level before your parser backend even knows what's going on. So first thing I'm going to do is I'm going to go all the way down, and don't worry, I did make some changes in the tokenizer. We're going to go over that later. But the first thing I'm going to do is I'm going to print out what the actual data is doing. So give me a sec and I will be right back. All right, so I went ahead and created this for loop here, and basically what it does is it prints out each token sequentially. So first we're going to actually print out the token value, then the token type, then the ID, and then the line and the column. Now in my language, I have two different types of tokens. You actually don't need to do this. I have the token type, which basically represents the type of data that we're processing. So is it a physical, it's pretty much if it's a physical character. So that's what that's for. And then I also have a concept of token IDs. So basically a token ID is a higher level construct or a higher level representation of the token that I'm processing. And I use token IDs to process information a lot faster, so that way I don't slow down my parser. So I basically have this token is an identifier, an integer literal, hex literal, and you see the rest. Now some of these I don't use, which is fine, but for the purposes of this video, we only care about two main token ID types. We care about string literal type, which is type number 6, or the value of 6, and then we also care about single, which is the type of 13, which is what most of everything that we're going to see is going to be. And then of course identifier is going to be type 0. That's going to be any letter or sequence of letters. So if we go back through here, we're going to actually compile this. So let's go to our tokenizer. Let's put a breakpoint here and let's run our compiler. So when we do that, first thing I'm going to do is I'm actually going to show you guys what the compiler is outputting, and then I'm going to show you how I actually added this feature into the language. So if we go here, we see that this is on line number 7. So we're going to scroll down here to line number 7. We can see we have our print line, and then we have our left paren, as you can see here, and then we have our type of none. So the token type is not a single character, it's a higher level construct. So this token type is of ID 6, and if we go to our token IDs, we can see here that number 6 is in fact a string literal. So it's basically creating a string literal here, and then it's doing a plus, and then message, and then a closing brace. So this is kind of what we're doing. So it's effectively doing this behind the scenes. It's saying this plus message, and that's it. That's all it's doing. So one important thing I want to note before I actually get into the mechanics of how this works is that if you're going to add this feature, you're going to need to have a concept of strings in your language. And you're also going to need to have a concept of string concatenation. And string concatenation is basically taking a string literal and concatenating values onto that string through passing it some set of data. So we'll get into how to add the mechanics of string concatenation later, but I wanted to put that out there because that is literally the only way this feature will work. All right, so let's actually get into it. And before I actually show you guys, let's do one more example. So let's do $, and now I'm going to show you guys the expression version of how you actually do this. So let's say we wanted to get the size of message. So we could say size of message is, and then we say message dot size, and this effectively creates a expression and concatenates that to the actual string value. So considering that you guys already saw how I transformed it before, I'm pretty sure you can guess what's going to happen here. So if we go stop this and we actually run it again, and we go up here again, line 7, and we scroll down, you can see here that we have our print line. Then the compiler creates our left paren, and then here's our string literal. So this time you can actually see that there's a string literal being concatenated. So again, remember type 6 or ID of type 6, which is string literal. And then we have our plus, and here is the important part. So we have our parentheses, and then we have our message, which is of type 0, which remember that's an identifier, dot size, and then we put our little brackets here, and this is basically just calling the function, and then we have another close brace, and then our final close brace here, and of course our semicolon. So as you can see, pretty much all the compiler is doing is, instead of doing this, it's effectively generating this type of code. So we're basically just doing that. And it actually, and if you guys noticed, it put parentheses around this, and there's a reason for that. So let's go back here. So the reason why you would want to put parentheses around this is, what if I did something like this, size plus 5, right? Well, if I did that, then if the compiler generates something like this and it just adds a plus, well, that's not going to work. You're going to get an unexpected result. And basically with string concatenation, what's going to happen is you're going to add this, you're going to create a string with this message. Then you're going to concatenate the size of string to that string. And because of the way my orders of operations work, you're not actually going to be concatenating the size of this string. You're going to be concatenating the size of this string plus 5. So this string right here, you can actually see down here, well, you can't see it on the screen, but it's 13 characters long. So you're going to get 13 plus 5, and that's going to be what the message of size is. So we don't want that. So we want to protect against that and always put parentheses so that we protect ourselves in case the user does a more complex expression. Because remember, we're at the tokenizer level, so we don't even understand what the hell any of this information means. So we don't care as long as we know that the user is going to have a $sign and the curly braces. We want to always put inside of those curly braces a parentheses just to protect ourselves, just in case that the user decides to do something a little bit more complex. All right, so let's go back into it. So I'm gonna type this here again, message, and let's go back to our tokenizer. So I'm gonna scroll back up here, and I'm going to actually look for where I process the string. All right, so here's where I process the string. So let's actually go into the logic. So I think we went over this before. If we didn't, I'll do a brief overview of my tokenizer after this video. But just know that this is the code that processes a string. You can see here I have a $sign is equal to current. So our compiler sees that we have this character here. So what the compiler does is it says, all right, I am on this character. Let's expect to process a string next. So what we do is we say, okay, we're down here. We process some information, and then we get down to here. So we look to see if it's not escaped. So if we haven't escaped, so for instance, if you had like something like that, and now that we're supporting $, you also have to escape a $sign if you don't want to print this. So if you do $message, then what you're effectively doing is you're literally printing the string message is $message. So what we're going to do is we're going to say, is this the current? We advance, and then we check to see if it's a curly brace. Now, before we get into the curly brace, because that's a bit more complicated, let's go to the easy part first. So we're going to first save our string. So let's go back here. So we have our $ message, and we know what we have a string that holds the actual value of the data that we're processing. So basically, as we iterate through every character in our program, we're going to basically check, is this the end of the string? Because as we know, strings end with both a first and a final string value. So we're going to basically just check every single character, and we're now at the point where we're processing a $. So we then say, okay, we'll save the string, and basically all that does is we pass in the string that we've concatenated with the previous values. So we pass in all of this information. So that's what we're doing. And then we pass in whether or not we found an escape in that string. And what that does is that basically just processes an escape string. So if we found an escape in our string, then we basically just iterate through the string and we add in or replace all of the escaped values. So we'll go through here and we basically just look for any point in the string where we have a slash. So let's say we did like this, size / new line of message. So once we reach the slash on this part, we would actually remove these two characters and end up effectively doing that instead. So let's go back up to the top. So otherwise, if we're not saving a string and we haven't found an escape, then we just create a token with the actual message, which is what you guys saw. So we basically create this token right here with the actual string value. And we, of course, set the string literal and we set the colon and then the line. So now let's go back up to the top and we can check out some more of the logic. So now after that, we clear the string because we want to start fresh again. And we basically add a plus sign. So immediately once we process this, we're adding a plus right here. After that, we check to see if we're not at the end, and if it's an alpha number or an underscore, basically what that means is we're expecting an identifier. So basically we're expecting a word to follow immediately after we add the plus sign. So we're going to run our code for parsing an identifier, and we'll get into that code a little bit later, but that parses an identifier, and then we error out if the user did not have what we expected. So we basically just tell the user, hey, the text preceding $ must be an alphanumeric or an underscore only. So it needs to actually be a word or a variable name for us to process it. And then here's where it becomes very important. So as we're processing this and we're saying, here's our message. So the size of message, or this is actually not a correct, this is actually a better representation of what we're trying to do here. So message is, so if we check to see, so immediately afterwards, if the next character after we process the identifier or after we process message is equal to a closing string literal, then what we do is we advance, so we consume that value so that we don't accidentally start processing it and error out, and then we go to start. And basically what that does is that starts the entire compilation process all over again. So we basically check for white space and we try to figure out what's the next character that we're processing after this symbol here. After that, otherwise, of course, what we do is we add a plus sign and we don't do anything, right? So if you guys remember, we cleared out our string, right? So we're effectively creating a new string. So like, let's say we put some other text here. I'm not going to put anything specific. But if we're processing more data after we processed our variable name here, then we just continue as normal, as if it was a regular string. And what effectively happens is the data that's afterwards gets processed once the end of the string is found. So we just add the plus here because we know we need to concatenate it, and then we continue along, and then eventually once the compiler reaches the end, it adds that value from breaking it. So again, if you guys remember, once you break out of the string, we save it here. So we check to see if we're at the end of the file. And if we are, we just complain and say, hey, we didn't expect that. Otherwise, we just save the string, and we've already reviewed that function. So we do that, and then we advance, because of course we don't want to process that same character again. And we go back to start, which I showed you before. So now let's actually look at the tokenized output of that. So I'm going to put a more legible word here. After the string message, and I'm going to recompile this. I did not spell that word correctly, but that's all right. So if we go back up to the top and we go to line 7, you can see here we have messages plus, because we need to concatenate message plus, and then we have the after string here. So we have the after string message here, and of course we have our other characters preceding that. So you guys can see that it's pretty straightforward. It's not very difficult to add this to the language. Now, it does get a bit more complicated when you want to add the feature for doing complex expressions. So let's actually go back up to the top. So we previously looked at when you just have a single $sign and you want to print out the value of some field. But let's say we wanted to actually do something like this, and we wanted to print out the size of the string. So let's go back to that example. Size of message is, and then message dot size. All right, we come here and we figure out, okay, this must be a string, so we're going to expect to process a string. We set up a couple of variables here, do some logic, and then we come down to here and we basically say, okay, it's not the end of the string, so it must be something else. So we check for the $sign. Of course, we run into that. And then we check to see, oh, okay, well, it looks like we have a bracket here, which means that this is a complex expression that we want to put inside or embed this data inside of the string. So this is actually pretty simple when you look at it at face value. Basically, we consume this character, we save the string, and then we clear out the string, which, to be honest, this is completely unnecessary because we're not even inside of the scope of processing a string anymore. And you'll see it's down here. After that, we have this variable now, dynamic string is equal to true. And then we add our token plus, and of course, we're going to need to add our left paren. And then we go to start. So that's why I say, you know what, I'm going to actually remove this because this is completely useless. We don't actually need that code there. So let's go back and let's recompile this to actually see what the output is. So we're gonna wait for the compiler to load. All right, so we are here and we can see that we have our print line, our bracket, or left paren. Then we have size of message. So of course we have our text preceding the complex expression. We add our plus and our left paren, as you saw that we did earlier. Yeah, so here it is. So you see that we're adding our plus and our left paren, and then we add our message variable dot size, and we add our 2 brackets because it's a function call. And then of course we want to close out our function call for print line. So let's go back and let's see how everything's done. So literally the only variable that I added for this to work are 2 variables. I added a Boolean called dynamic string and then a long called brackets. And now this is very important because in my programming language, I also have a concept called dynamic or anonymous arrays. So you can do 1, 2, 3. Now, under normal circumstances, you probably wouldn't do this because it's a bit silly. Of course, you can concatenate this data to the string, and the string will print out the data as an array. But a better example of why you'd want to have brackets or a counter for how many brackets you've encountered is, let's say we created a new class called car. And car, we want to initialize it. And if you guys remember, we can initialize classes through this type of initialization. So we can just say wheels is equal to 4, and we can say license plate. Oh, I just messed up that. That's fine. You guys get the point. License plate is equal to 5, 6, whatever, right? You guys get the point. So under normal circumstances, this probably would break the compiler if you guys didn't add the brackets feature. So I'm actually going to compile this so you guys can actually see. Oh, and you could create a complex expression in here. So if you guys remember, you can initialize classes this way, where you don't need a constructor. You just say, I want to create this new object, and you assign the fields to the values of that object. And you guys can see I already compiled it here. And this is a complicated string. So we have a string here, we have our dynamic string starter here, and our dynamic string ender here. And because we're keeping track of our brackets, we know that this string is completely separate from this string. So I'm going to delete this, and I'm probably going to just put message.size to keep things a little simple. And let's actually go to see where the rest of the logic is to keep track of when we're at the beginning and end of our dynamic string. So I'm going to stop this. So now we need to find where this is being used. So if I do a control find and I search for dynamic string, we can see up here it's used in a couple spots. So first, when we go to start and we're invalidating white space, if we enter a new line, and if dynamic string is enabled, we want to set dynamic string immediately to false and brackets equal to 0. And then we also want to complain and say illegal string format expected comma or this value before the end of the string. And the reason why I have that here is because my language specifically does not support multi-line strings. So you can't do something like print hello and then hit enter comma world. Like you can't do that. So that's exactly, and you can actually see the syntax highlighting is kind of screwed up. So because my language doesn't support multi-line strings, that's why I immediately set dynamic string to false and brackets to 0. But you don't want to just immediately set dynamic string to false every time when you enter a new line, because you want to check to see if it's actually set to true so that you can error out and tell the user, hey, you screwed up here. Because if we actually go down and look at our normal code here, and we actually just pass the additional logic for dynamic strings, but if we look at our code for strings, and you can see here, right, while we're processing it in our for loop or our while loop, if we ever at any point enter a new line, we complain about it in here and we say illegal string format. We expected something else before the end of the line. So we wanted the string to basically end before the user hit new line. Actually go up to the additional logic. You can also see here that I have if dynamic string and brackets is equal to 0, we basically am checking to see if we're processing a dynamic string and brackets are equal to 0, which means we've processed every single bracket and we've run into this value here, or we've run into another string. We basically want to complain to users and say, hey, we expected you to end your dynamic string with this character. So now let's actually go back to find the dynamic string code. Let's look at our new one. So here is a very important piece of logic. So we have our if there's an opening bracket. So if we go back to our example, if you guys remember where I had the new class, I'm not going to type it again, but where I had the new car and then I had the data inside of there. Well, whenever we enter a new bracket or whenever we find a new bracket and we know we're processing a dynamic string, then we basically want to increase the value of brackets. That way, the user can nest as many of these freaking things as they want, and it has no effect to processing the dynamic string. And then after that, we basically look to see if there's a ending bracket. And if there is, then we want to say, all right, is it a dynamic string? If we're processing a dynamic string, then we want to check to see if brackets is equal to 0. And this is important because if we're processing, whoops, I'm going to close that. If we're processing our dynamic string and brackets is equal to 0, then we know that we're at the end of our dynamic string. Let's look at the case where it's not. So if it's not, then what we basically do is we just add that right curly as normal, and then we decrement the bracket because we know that we need to continuously lessen the amount of brackets that we're processing. So the next time we come into here, and if we check that brackets is equal to 0, we can actually handle that situation properly. Now, under normal circumstances, if it isn't a dynamic string, it does the exact same thing that it's doing here, where it's literally just adding another token of right curly. The only difference is that this code does not decrement brackets because it's not inside of a dynamic string. So you want to make sure that you do that. Afterwards, we basically set our dynamic string to false because, of course, brackets is equal to 0. And we then consume, or we first check to see if we peek forward one character and we check to see if it's equal to a closing brace. And this is very important because if it is, then we want to advance twice. So we want to consume this character and this character. And then we want to basically add this closing brace here, or this closing right paren, because if you guys remember, for every dynamic string that we have where we have complex expressions, we always want to surround it in these brackets here, or these parens. That way, just in case the user does anything crazy, we can cover ourselves. So after that, we just go to start like normal. And if it is not equal to this, so in the case where we're not at the end of the string, so in this case we would be, but let's say we have some more text behind here after this dynamic string, then we would actually just add the closing brace and then add a plus. So that's important because, again, we're still concatenating the string. So we would basically do this where, oh, I hate it when it does that. We'd basically do this plus message.size, and we'd add this here, and then we'd add that there, and then we do another plus, and then we just continue processing the string as normal. So you can see after that we call process string. This is important because we need to finish processing the string. So if we go back to here and we put this back, $, and we put our dynamic string back, we need to continue processing this string because the compiler is not going to know exactly what to do. Because if we don't directly go to process string, what's actually going to happen is the compiler is going to process this as a space, process this as an identifier or as a word, and then it's going to break because it's going to expect some data after this to be a string, but the line ends here, right? And if you guys remember, we can't have new lines inside of our strings, so we don't want to do that. So we basically have to force the compiler to go directly back to processing a string so that we don't break anything unintentionally. So now let's do a recap to see how all this logic works. So if we go back here to dynamic string, first we come in, we process a string, we check to see if dynamic string brackets is equal to 0. Now I'm actually going to show you an example of this. So let's actually do this. So I'm going to do that and I'm going to hit play. So as you guys can see here, I got to scroll all the way to the top. As you guys can see here, and I'm also compiling other files as well, but you can see that we have our illegal string format expected this value before the end of the string because we know that once we reach the first bracket for our dynamic string, we want to increment bracket. So the reason why this happens is because as we're processing our dynamic string, as soon as we encounter this, we're going to set dynamic string to true. So if we actually go to where brackets is initialized, we can see brackets start with an initial value of 0. So we don't immediately increment brackets here, and you definitely don't want to do that because there's no brackets being processed. This is just the syntax of how your dynamic string is processed. So if we did something like this, then we can process brackets and say brackets plus 1, brackets minus 1. Otherwise, you want to leave that value alone and just let it be what it is. Otherwise, if everything is all good, Then we continue along, and here we go. Where is it? Okay. So we continue along and we check to see what type of string that we are processing. We save the string for simple strings where you just have a single value, such as this, where it's just $. You're going to expect the value right afterwards. We clear the string because we're going to continue looping. You add the token of plus, you expect an identifier, and then you basically check to see, are we at the end of the string? If we are, go to start. Otherwise, we would like to add a plus and then continue processing the string as normal. And then if you have the example where we have the complex expression added on the inside, then we would basically advance, consume this token, save the string, set dynamic string to true, and add our plus in our left paren. All right, so before I go, the final thing that I want to share with you guys is I'm pretty sure some of you guys are wondering, well, what happens if I have an error, right? Because I'm sure some of you have seen before where you have basically an error here. You basically tell the user what's wrong, and maybe your errors have some type of numbering system. And then, of course, you tell the user what file it happened in and specifically what line and what column it happened in. But then you also have this value here. Now, this error doesn't pertain to something happening here. I was doing something a few minutes ago, but what's important is that you can see here that you have the line of which the error happened on, and then you have this little pointer that points to the value of where the error happened. So if we go back to our tokenizer, I'm going to hit a breakpoint here, and I'm going to stop it. Now, because where I am at the state of the compiler, I can't break this code and then show you that the compiler is printing out an error because I'm not that far along yet. But what I can show you is, let's say instead of message.size, as you can see here, I already did it. I did message.sci. Now, sci is not going to be a function that's going to reside in the string class. Size is the actual function. So if we can't figure out what sci is, well, when we go to actually print out where the error happened, we're going to need to know where that sci function was being called. So we're going to have our error pointing to that. So if we go here, we can actually take a look and we can see sci is at line 7, column 47. So you guys actually can't see it here. I'm going to lower my window so you guys can actually see. But if you look here, sci, and you can see here, column 47. So once we get the actual error inside of our dynamic string, literally our little pointer can point directly to where that error was happening, despite the fact that we were adding a ton of characters before and after, because the spot at which we were adding those characters resided in the exact same position and column that the dynamic string started. So I don't want you guys to worry about, well, what if my user has an error and they have like this really long dynamic string? No, your compiler is going to complain exactly where the error happened, and it's literally going to point to that error inside of the string that the error happened in. So the user's not going to know that you're adding, a in string here, and then you're adding, a plus, and then you're doing this, and you're adding a thing here, and then you're doing that. The user's not going to know you're doing all of this. All they're going to see is, oh, look, I messed up, and looks like I have an error right here where psi is not defined. So that's something I wanted to put out there for you guys in case any of you were wondering. But yeah, that was dynamic strings. So I hope this was very informative. I hope you guys enjoyed the video. The next episode, we are going to start talking about our parser again. And I got a really good video for you guys on the next episode talking about tools and building a better compiler. So definitely look out for that. That video is going to be next week. I'm going to try to come up with a solid schedule where you guys can expect my videos. I haven't picked a day yet, but one thing's for certain, I will make sure that my videos are always scheduled to start at 8 in the morning Central Time. So definitely look out for that. Also, if you guys would love to help out the channel, you guys can go to my GitHub page. It's here. You guys can actually check it out. If any of you guys are interested in watching the development of the actual language and me pushing out updates, I put releases from time to time. They're typically pretty spread out, but they come with some pretty big updates. You guys can check that out. Also, if you guys would love to have a more up-to-date experience on what's going on with the language, definitely navigate to my doc folder and navigate to the change list folder. Now, this is a master branch. I rarely update this master branch. So if you guys want to see more up-to-date commits and what's going on with the language, only go to remastered and check out the change list. The change list is basically going to hold a high level view of everything that I've been doing in the language thus far. And you guys can see from August of last year to about now that I'm starting to do the videos again, you can see I've done a plenty amount of work. And this is actually outdated to add more stuff that I've added and moved to the language. But yeah, if you guys would love to help me out, definitely star the repo and watch it and fork it as well. That's definitely going to give my language a lot more visibility, and it definitely helps out the channel a ton. So that's it for this video today, guys. Hope you guys enjoyed it. Definitely like, comment, and subscribe if you guys liked what you saw and you want to see more. And until next time, I'll see you guys later.